Did you know you were in for a treat today? Well, you are. We're talking about exponents finally. So, you're going to love exponents. Okay? Let's talk a little bit about them real quick. I'm going to zoom way in and just jot a couple of things down. Okay? So, hold on. Let's zoom in. All right, here we go. So, let's talk about exponents. Real quick, let's just remind ourselves what is even going on. If I asked you 4 to the third power. First of all, a little bit of vocabulary. This number, that big number there, big meaning like we write it bigger than the other one. It's not necessarily always, I know 4 is bigger than 3, but it doesn't have to be that way. Could have been 2 to the third, right? Anyway, that number right there is called the base. Okay, so we've got the base. And then, you also have the little number that we write small up to the right here. That one's called the exponent, right? I know this is old news, but just to recap in case anybody forgets. So that's called the exponent. And remember what this really means to do. An exponent, it doesn't mean 4 times 3, this is not 12, right? If I wanted you to do 4 times 3, I would have just written it as 4 times 3. I wouldn't have gotten all fancy on you. So the reason why it's fancy is because it doesn't mean that. It means to do the base times itself, the number of times that the exponent represents, right? So 4 to the third means to do 4 times 4 times 4. That's what it means. And you could do that out. You could evaluate it. 4 times 4 is 16, and then 16 times 4 gets you a final answer of 64. I'm actually less concerned about that. But here's what's something that is kind of cool. What happens if you have something like 4 squared, and then you multiply that by 4 to the third? What happens here? Well, think about what that really means. 4 squared really means 4 times 4, right? And then I'm going to multiply that by 4 to the third. Oh, it's, you know what? I should do this in different colors. Hang on. Give me a sec. Hold on. Ah! Hold on. Let me put that 4 to the third back, but I want it in red. Okay. So if I have 4 squared and then I do, I multiply by 4 to the third. 4 to the third is 4 times 4 times 4. Okay, do you see that? But when I go ahead and I multiply all of these together, doesn't that just get me 4 to the fifth, right? I've got 1, 2, 3, 4, 5 of them. So that equals 4 to the fifth. I wish there was a way for me to bypass all this and just go from this right to that. There is. What do you think I'm doing with this 2 and this 3 to get 5? If you said add them together, that's exactly it. That's all I have to do. This, okay, hold on, that I squiggled out. This right here is why that works, though. Okay, but I certainly don't expect you to be writing that out every time. What if it was like 4 to the 10th times 4 to the 27th? I don't want you writing out all of those 4s. That would be crazy. But if you know the rule, you can bypass all that. Okay, so check this out. Hold on, let me erase some things. Okay, so here's our general rule. Just if you're taking notes, you should have this written down in your notes somewhere. So if I have some variable raised to an exponent and I multiply it by a number with the same base, so it also has to be the same base, the base can't change. If I raise that to a different exponent, my answer is just going to be whatever that base is to the power of x plus y. Okay, that's important. So again, if I just gave that example, 4 to the 10 times 4 to the 27th, I would never want you to write this out. But now that you see how to do it, as long as my two bases are the same, which they are, they're both 4s, so my answer is just going to be 4, but then the exponent is just going to be the sum of 10 and 27. Well, that's easy enough. So 10 plus 27 is just 37. Please do not try and do out 4 to the 37th power. It is a number that is so big, you could only really express it in scientific notation. It's enormous. Don't do it. You would just leave it, right? Just leave it as 4 to the 37th power. What you should do out are small ones. Like if it was 4 squared, you should write that as just 16, okay? But if it's a number that's way too big, even 4 to the 4th, I wouldn't want you to do out. So 4 squared, sure. 4 to the 3rd, fine. Anything bigger than that, that's too much, right? It gets too big too quickly. Okay, let's try another one. What if you had something like 12 to the 7th times 12 to the 5th times 12 to the 2nd? This time there's 3 of them. It doesn't matter. You can have as many as you want, as long as they all have the same base, which they do in this case. It's just 12. And then all I have to do is add these exponents. So if I add 7 plus 5 plus 2 together, doesn't that just get me 14? Yeah, this is so cool. And it also works for variables. So let me erase this. What if I did something like x to the 9th times x to the, I don't know, 7th? Doesn't matter. My bases are the same. They're both x's. So that would just be x to the 16th. Because I'm just adding the 9 and the 7 together. That's it. Here's one that does confuse kids an awful lot. If I did something like x times x to the, I don't know, 8th. A lot of times kids don't know what to do here. Well, what is the exponent right here? Hopefully you're saying to yourself, it's a 1, right? There is always a 1 there. We just never write it. So if a variable doesn't have an exponent, it actually does have an exponent. It's just a 1, and we don't write it because we're lazy, okay? There's no need. So because it's an accepted rule. So they have the same base, and just knowing that there would be a 1 there, 1 plus 8 gets me a 9. Okay. Trying to think what, oh yes, let's talk really quickly about, you can have 0 as an exponent. What? What in the world do you think a number, actually let me do it not with a variable first. Let's take the number 4. If I had 4 to the 0 power, what do you think that equals? Like if I typed in, don't do it yet, but just guess. If you type in 4 to the 0 power in your calculator, what do you think is going to pop out? Most of the times kids guess 0, and that is incorrect. 4 to the 0 power is not 0 at all. Other common things are undefined. 4 to the 0 power is not undefined. It very much has a value. Okay, now this is going to blow your mind. You ready? You ready? You ready? The answer is 1. What? What? Let me do another one before I explain why it is what it is. What if I did like 100 to the 0 power? It's 1. What if I did like, I don't know, 2/3 to the 0 power? It's 1. Doesn't matter. Any number raised to the 0 power. You can even do a negative number. I don't care. Negative 19. Raise it to the 0 power. It's going to come out as 1. What? What? Why? What is this? Sorcery. No, it's not. Let me show you. It is mathemagic, that's for sure. All right, here's what's going on. And this ties into a little bit of a lesson that you're going to get more in Algebra 2. I mean, we would have done it if we had more time together, but it is what it is. So one thing that is going to end up happening is if you're dividing two numbers with the same base. Let's stick with 4s. Hold on. I'm going to do it as 4 to the 5th over 4 to the 3rd. Okay, there's a rule that we're not going to get too far into, but there is a rule that if you divide two numbers with the same base, you can actually subtract their exponents. So if you had this would actually equal 4 to the 2nd power. Okay, because 5 minus 3 is just 2. If I had 4 to the 5th over 4 to the 4th, that means I would get 4 to the first, right? Right? Okay. And then what if I had 4 to the fifth over 4 to the fifth? Well, that gets me 4 to the 0. Now, I'm claiming that this equals 1, and it does. And let me explain why. Think about a fraction. If you have the exact same thing on top and bottom of a fraction, isn't that always equal to 1? Like 8 over 8 is just 1. 20 over 20 is just 1, right? X over X is just 1. If you have the exact same thing, top and bottom, it just equals 1. Oh my gosh, so cool. There is an exception to this. 0 to the 0 power. And the reason why that's is an exception is, remember, I can't ever have 0 in my denominator, so I can't do this with zeros. So 0 to the 0 power, that one is actually undefined. But any other number in the whole wide world, if you raise it to the 0 power, it's just going to equal 1. Okay, so now let's get to this worksheet. Let's try some of these together. See what is going on here. All right, so if I look at number 1, now notice I have multiple things going on. I have 3's and I have B's. One thing that I want to point out to you is that you can rewrite this. 3 times V to the third times 3 times V squared. Sometimes writing it like that makes it a little bit easier to see. And remember that you can change the order, right? I can change this around. So I'm going to swap these two. I'm going to put the V to the third there and then the V squared. If it's all multiplication, I get to multiply in any order that I want to. So now 3 times 3, that's easy. That's just 9. And then this is what we were just talking about. If I have V to the third times V squared, well, the rule tells me that I'm just going to add those exponents together. So that becomes V to the fifth. Now, I don't need you to do all this out every time. You certainly can, but you don't need to. Here's the way that I handle all of these. Okay, let me show you on number 2 how I kind of work through this. So I take a look and I multiply any of the numbers together. So the only number in this case is 2. So there's nothing else for me to multiply it with. So I'm just going to have 2. And then I'm going to multiply my variables together. I have m to the third and m to the first. So if I multiply those two, I'd get m to the, hopefully you're saying fourth, right? Because remember there's a secret 1 there that we never write. So 3 plus 1 gets me 4. All right, let's try number 3. So this one, just like the last one, I'm going to multiply the numbers together. In this case, it's only a 3, so I still start off with a 3. And then n's. I have n to the third and n to the first. So put that together, that would give me n to the fourth. All right. Okay, 4. This is a great one. So I'm going to start off, I'm going to multiply my numbers together. 2 times 2, that gets me 4. And now let's deal with k to the third times k to the third. So they both have a base of k. And then 3 plus 3 gets me 6. So that's that one. Okay, so once you do a couple of them, they're really not so bad. And I did want to go ahead and do certainly 8 together, because I know that one looks super intimidating. But it's really not that bad if you just follow the steps that I mentioned before. So any of the numbers that I see, so I have a 3 times a 3 times another 3. Remember, this is all multiplication, so I can do it in any order I want. So 3 times 3 is 9, and 9 times 3 is 27. So 27 is going to be my first number here. Now you want to work your way alphabetically, right? So next I would deal with the x's. So I have x to the third, x squared, and x squared. So if I put all of those together, add 3 plus 2 plus 2, that's going to get me x to the 7th. And then I'm going to do the same thing with the y's. Let me just switch colors here. So I'm going to do the y's. I have y squared and another y squared. So if I put those together, that would get me y to the 4th. And this whole thing is my final answer. Say it wasn't so bad, right? Let's jump to 10. And you'll notice in 10 that this one has a 0 exponent. Okay, so how do we handle that? Here is the best way, in my opinion, to handle the zero exponents. First, I want you to think about who has a 0 exponent. Who does? And the answer is just this y right here. This y is being raised to the 0 power. Not this x right here is not being raised to the 0 power. It's being raised to the 1st. The only thing, if I wanted to raise both the x and the y to the 0 power, you'd have to put them in parentheses. That's actually our next lesson. But here, only the y is being raised to the 0 exponent. So remember, what any number raised to the 0 exponent is, it's just 1. Right? So 3x times 1 is just 3x. So I literally go in and I just cross them off because they just turn into ones, right? And anything times 1 is just that thing. So I don't really even have to worry about them. So if you see anything to the 0 power, you can just ignore it. All right, and now I'm just going to continue like I was before. So let's multiply the numbers together. 3 times 2 gets me 6. And then x's. I have x to the 1st and x to the 3rd. So put those together, that gets me x to the 4th. And then this y to the 3rd doesn't have any other y's to go with. So it just stays as y to the 3rd. See, wasn't that neat? I'll do one more with a 0 exponent just because they are a little strange. Are there any others with it? Oh yeah, 9. Okay. So I'm looking at 9. I'm like, oh, I see another 0 exponent. I'm literally just going to cross it off. Because it's just a 1, right? So now I'm going to do the 3 times 2. That's 6. A, there are no other A's, so that A is just going to stay there. And there's no other B's, so it's just going to stay as B to the 3rd. That's it. Okay, so give these a shot. Let us know if you get stuck. Exponents are fun when you get the hang of them, but it does take a little while to sort of understand the rules and how they work, okay? So give this your best shot, and then tomorrow we'll talk about the next rule.